Fucking with all these, money don't count itself.
Hello guys, welcome back to today's video. This video is based on the chapter Rotational Motion or Rigid Body Dynamics. This is the first question, which is one of the simplest question of this chapter, which appeared in 2002 JEE Mains. So let's begin. The question reads as two identical particles moves towards each other with velocity of 2v and v respectively. The velocity of the center of mass is. It's a very simple question with the simplest formula of this chapter, that is v of COM is m1 v1 plus m2 v2 by m1 plus m2, which gives the velocity of the center of mass. Now the two particles are moving towards each other. Suppose this particle is moving with velocity 2v and this particle is moving with velocity v towards each other. So, and if we take this direction as the positive direction, so this will obviously be the negative direction. So with writing with the proper sign m1, that the two particles move towards each other with velocities we give, it's given. It's very it's not clear here the masses are equal or not, but we will take them as equal mass only because it's not clearly mentioned of different masses. They are of different masses. So m of minus v, because this is in the negative direction, by m plus m. So 2mv minus mv by 2m, right? So mv by 2m, or this is v by 2, which is given in option C, right? Thank you. Now the second question reads as initial angular velocity of a circular disk of mass m is omega 1. Then two small spheres of mass are attached gently to the diametrically opposite points of the edge of the disk. What is the final angular momentum of the disk? Now this can be categorized in an easy question only. So before giving the solution, I would like you all first try this question by yourself and then go for the solution. Now let's visualize the situation. Suppose this is the disk and this is the axis of rotation, which is rotating with omega 1. It's given omega 1. Now the disk is rotating. Now the disk, so the moment of inertia is I1. Suppose I1 is that the mass is given m, so half of, for disk we know that half of mr square, or here this is the radius, suppose r, so half of mr square. Now the second situation is when two small masses of small m, right, small m, are placed in the diametrically opposite sides. So the new moment of inertia I dash, suppose I1 dash or I dash is half of mr square, the disk's moment of inertia plus the moment of inertia due to the two masses. This is mr square for this mass and mr square for this mass, right? So it's half of mr square plus 2m r square. This is small mass of the two balls, right, or balls are the particles which are placed on the diametrically opposite sides. Now, as while placing these masses, there is no external torque acting on the body, so the angular momentum will be conserved, right? So I1 omega 1 will be equals to I2 omega 2, right? Now I1 is given half of mr square, and omega 1 is given the angular rotation of the first disk. Now for the second case, it is half of mr square plus 2mr square and omega dash. That is the final angular velocity which we are trying to find out, right? Now omega dash is equals to half of mr square omega 1 by half of mr square plus 2mr square, right? Now simplifying this, we will get half of mr square omega 1 by half of, no, this is m r square plus 4m r square by 2, right? Now this will get cancelled, and m r square will get cancelled. So this r square will get cancelled, so it will be omega plus m plus 4m, omega 1 m plus 4m, and above there is m. So we can see that it matches with option C, right? So this is the solution for this question, which is m omega 1 by m plus 4m. Thank you. This is the third question, which reads as moment of inertia of mass m and radius r about its diameter is. Options are given. This is a very simple questions, and the probability of coming this type of questions in recent year JEE mains is quite low, but still you may never know, it may appear. And so first you try, and then I'll be giving the solution. This is very simple, and suppose this is the disk and this is the axis of rotation, right? Now we know this is a ring, sorry, this is a wire, this is a ring made of a wire. So when from the perpendicular, when it is the axis of rotation, the moment of inertia is m r square for a ring. Now now for finding out the diameter and for finding out the moment of inertia along the diameter, we know that we have to half it, right? So I will be simply m r square by 2, nothing else, which is given in option A. Thank you very much. This is the fourth question, friends. The question reads as a particle of mass m moves along PC with velocity v as shown. What is the angular momentum of the particle about O? This is the O point, and the particle is moving mv. Okay. Now angular momentum, we know angular momentum is given by linear momentum into the perpendicular distance from the point along the line of the velocity, the perpendicular distance from the point along the line to the velocity in which the particle is moving. So here the perpendicular distance is L. We all can see as the velocity is along this direction, and from O the perpendicular distance is L, right? So mv into L, this is simply we can find out, or we know that L is equals to m of r cross v, right? And or mr v sine theta. Now this is r, and suppose this is theta, so r sine theta is nothing but mv into r sine theta is nothing but the L, which is the perpendicular distance which we derived here only, So this is mvl. From both this method we are getting the same answer, which we'll be getting obviously. So the answer is nothing but option given in option B, right? Which is mvl. This is mvl square, my friends. Sorry for this, which is given in option B. Thank you very much.